Thank you. Now, you already know about myself from yesterday. I won't take the time. Tomek is a colleague of mine working with Adobe in Poznań in Poland. He's also closely involved in the Jackrabbit and Sling communities, author of a couple of Sling modules, and famously he implemented a solution to the Towers of Hanoi problem in Sightly. If that's not cool, I'm not sure what is. But anyway, enough of us. This is today's agenda. We'll be talking about a bit more about the motivation behind developing this zero downtime deployment solution. We're going to have this sort of ground laying the concepts of our implementation. We'll have a demo, and then we'll wrap up with some conclusions and documentation. Now, when I was introduced to the world of Sling and AEM and JCR, I think about 6 years ago, I sort of took a paradigm change. So it's very much different from regular JEE applications. Now, in Sling, everything is a node or a resource. So you take all of your content, your binaries, your bundles, your configurations, whatever your settings, and put them in the repository. And that is a good thing. But sometimes it makes things a bit more interesting. Deployments and upgrades are one such scenario. Now, consider a distributed Sling application working with a cluster repository, MongoDB, and you have 3 instances. Of course, there's a load balancer in front, all of that. I haven't drawn up all the details. So what you would know from classical GE applications is, well, let's do a rolling update. That means take one instance, take it out of the load balancer, update the code, bring it back, and wash, rinse, repeat. Do the same for all applications. Well, you might be forgiven for thinking that works in our scenario. And it works with a minor addendum, which means that whenever you do a change, you deploy a bundle or you change a config in a document node store, which is backed by a MongoDB or relational database, within 1 second, all other instances connected to the same node store will be notified on the change because, right, it's a cluster deployment. And then not only will this instance start updating its code, but all the others, which is not what you would expect from a controlled rollout of a code change. So it's not, don't really have a very good solution for doing updates in this scenario, except using maintenance windows, which is something that all of us would like to avoid. So cluster deployments, not so easy to do rolling deployments. Standalone deployments are a bit easier to manage, but here the paradox is choice. We have many ways of deploying these updates. We can use the OSI Web Console with the advantages and disadvantages. We can use the JCR installer. We can choose to wrap things up in a content package and deploy them as well. But on the other hand, we have all these disparate solutions. They offer varying levels of support for rolling back in case something goes wrong. So we decided to look for a simpler, more repeatable way, and I'm not sure if rollbackable is the word, but I'll just say the rollbackable way of deploying updates to Sling instances. And to do that, we're going to reuse a familiar naming pattern. You just saw it a bit earlier. Oh, no, sorry. This is a new slide. I forgot about this one. So our solution is basically keep everything in the repository. No, don't do any architectural changes to the way we build and architect applications, but instead take libs and apps, which are by default the locations for active content in Sling, OSI bundles, configurations, and put them in a different repository. So you would have this, the whole repository tree, which is your old Sling or AEM application, and then libs and apps, although they would appear there, they would be physically stored in a different repository. And that helps, for instance, with clustered deployments, because you can make libs and apps private to a certain instance, but keep the rest of the content tree in a global repository. So this way, we decided to create this new and shiny Composite Node Store, which sounds a lot like the Composite Blob Store, which is a sort of a way to delegating a part of the subtree to different stores. It's not a different persistence implementation, so under the hood, it delegates to either segment node store or document node store instances or other custom node store instances if you have the need for something like that. And the idea is that, OK, you take a number of stores. There's always a global one. So by default, everything goes to a certain global node store. And then you can take out chunks and say libs goes someplace else. Or you can even say Etsy design something goes to something else. And well, since when you package something into libs and apps, you also have some sort of auxiliary data. You have access control entries. You can have indexes, which, although they relate to the data in libs and apps, they belong to that data, they're not packaged under libs and apps. So you need to have a way of contributing entries that are outside of libs and apps. So we have, by convention, this :oak, :mount. So whenever a node with this name fragment is encountered, we know that it belongs to a different mount. Now, what we usually do in Sling and AAM, or what we advise, is that you have a global node store which contains everything, and then libs and apps are mounted as read-only, but they belong to the same logical mount. So we don't have two repositories, one for libs and one for apps, because it doesn't bring us anything. So we take libs and apps together and store them as the same repository. Also, indexes. So if you have the UUID index, for instance, that's the usual structure. And then instead of the ind, you would have the index node, usually, which holds the index data for the global store. You also have this oak, :mount, :libs, -libs, -index, which is the way a mount would contribute. You also have the permission store, but this one is a bit simpler. It's actually a mounted path, just like the ones above, because you have the name right in here. So you don't need to sort of fan out reads for different locations of permissions. So that's the way you would sort of split your application out if you want to have a private section for libs and apps. Something that is interesting here is that we made apps and libs read-only. I'll go into a bit more details about that later. But what it means is that you can't start up AEM and say, hey, libs and apps are read-only. It doesn't really work like that. So you would have a little bit of process, which Tomek will show you, which will actually create libs and apps beforehand. And then you would take them and plug them into an existing repository. So mounts are read-only. It would be quite tempting, and we actually have some basic support for making mounts read-write. But it would sort of be a lie to say that they are read-write, because it's, first of all, when you do a change in the JCR repository, it's supposed to be atomic. And getting multiple node stores to cooperate and still do this fast and scalable would be very hard. And we didn't really find the need for that, so we just skipped on that. Then observation would have to plug this into this as well. So we just escaped a whole host of problems by making this kind of mounts read-only. We don't support references and versions. We saw that AEM works just fine without having any referenceable nodes or versionable nodes in a mount, so we just decided to do away with it. Now, this is more of an interesting discussion, because technically you can have references between a global node store and the mount. But consider the fact that you would have one global node store and 3 mounts. If you create a reference from the global store to the private store, it would be only valid for one of those mounts, because potentially you can have different mounts on different node stores. So we simply don't allow ourselves to shoot in the foot that way. So we have a set of mount time checks. Whenever we assemble the repository, we do run a number of consistency checks. And we also have some runtime checks just to make sure that the repository remains consistent. What is usually more interesting is how your applications will need to change if you want to adopt this paradigm. Being implemented at the node store level usually means that there are no API changes, right? So it's the same Node Store API, the same JCR level API. Your applications will be able to work just as before, with the given fact that libs and apps are read-only. That, in my experience, has not been a huge issue with production code, but a big issue with testing. So if you want to run your various integration tests in this setup, you would typically deploy some components and you want to assert their behavior. And you do that by sometimes deploying a configuration and using the JCR installer to pick that up, or deploying additional bundles, or deploying scripts. And all of those go into apps typically. And well, you can't do that anymore. So at that point, you need to find a different solution for deploying test assets, let's call them, into libs and apps. One way is to pre-provision them using the provisioning model, or just creating the repository outright from content packages and then making it read-only. The read-only status can be created from your application, but not using session has permission, because it's not a permission issue, but instead using the wider session has capability method. So this way you can find out if libs and apps are read-only and gracefully react to it in your application. Now, I've spoken more than enough. I'll give this to Tomek.
Thank you, Robert. So in this part, I will try to describe how this new Composite Node Store can be used with Sling, AEM, or any other Sling-based application. The main challenge when trying to run AEM or Sling in the composite mode with the Composite Node Store is that if we want to have some composition, then we have to have at least two parts. And in this case, it's two repositories. So we need to have two repositories, and one of them, the apps and libs one, have to be already pre-filled with all the data. So normally when you are starting AEM, then it starts with an empty repository, and then it uses some embedded content packages to install the whole content, the /content, /home, /var, /apps, and so on. And in this case, we cannot really do this, because if we start AEM with empty repository, then it will try to install everything under apps and libs, and it will fail because it's read-only. So because of that, we need to split this process of deployment for composite AEM into two parts. In the first part, we don't use Composite Node Store at all, and this stage is only used to create our repository, which will be used later on. So the first stage is, in the first stage, we simply are starting the instance and stopping it immediately after it's initialized, and then we are taking this segment store created in the process, and we are treating it as another build artifact. And it will be used when we are trying to actually run the AEM based on the Composite Node Store. So this is the graph presenting the whole process. On the left-hand side, we can see the process of preparing, of building the composite instance, and in this part, we are actually starting it. So this thing has to be done just once, and once we have this segment store, we can start any number of the composite-based instances. So let's take a closer look on what happens in here. The instance is, as I said, is started without the Composite Node Store. There is a special script that waits until this instance is really started. And if you have ever tried to do this, I mean, wait until the instance is ready, you know that it's not an easy task, because there is a number of criteria that we can take. basically, for sake of this task, we assume that instance is ready when the start level is equals to 30, and there are no more indexing jobs in progress. So basically, it has started. It responds to /login page, and nothing else happens in the background. So once the instance is in this state, it is being stopped immediately, and the repository directory is renamed to repository libs. And this repository libs, we should treat it as a build artifact distributed everywhere where we want to start the composite-based instance. So it's a completely initialized repository. It contains the apps and libs part, obviously, because those parts will be mounted by the Composite Node Store. But also it contains everything else. Why? I will talk in a second. So we have this part covered. The only result of this part is this segment store. So we can now actually try to start the instance based on the Composite Node Store. So we have configured the Composite Node Store to use 2 repositories. The first one is the one that we have just created. And the second one is the content repository. It may be MongoMK or TarMK, as in the normal AM initialization. So now there is another issue. At the beginning, this content repository will be empty, because we just pointed, for example, to an empty Mongo database. And as I said, in the normal case, without any Composite Node Store, this part, which should contain the /content, /home, and so on, it should be installed from the content packages as well. But in this setup, we cannot use it because those content packages will try to install the apps as well, and it will fail because the apps is read-only. So what happens here is that if the content repository is empty, then it is being pre-filled from this one, because this repository contains everything. So basically what happens here is that the whole /content, the whole /home is being copied directly to the content repository. Later on, if the content repository is not empty, for example, if we start the same instance for the second time, or if we reference an existing Mongo database, then this step will be skipped. But we need to have some way to do this initial pre-filling for the content repository. Yeah. So I just said this, in case you want to come back to the presentation later on. And there is one more thing, but I promise you it is the last one of not so clear things in here. Since the apps and libs is a read-only area, we cannot really install any customer application when the composite-based AEM runs. So what we have to do is we have to install the customer application in this part as well, in this stage. By customer application, I mean whatever we build on top of AEM or Sling, so whatever custom solution, custom components, and so on. We can install it manually, of course, but there is a better way, and this better way is called Sling provisioning model. So this mechanism, Sling provisioning model, is used to basically build the whole Sling and build AEM quick start. It's a text format which allows us to define all the required content packages, all the bundles, like in here, all the OSGI configurations, ACLs, basically everything that builds the whole application together. So the idea is that the provisioning model for the customer application is being merged with the Sling or AEM provisioning model, and the whole instance starts with all the required things installed immediately, without the need to add anything else later on in the runtime. So this process may seem a look complicated, and certainly would be if someone wants to perform all the steps manually. And we needed some kind of tool that can be used to automate the whole process. And the other thing is that at some point we end up with this repository libs directory. It's not entirely clear what should we do with this. Maybe we can, I don't know, put it in some tar.gz package or zip package or distribute it in some other way. So basically we need two things. We need to the first thing is to encapsulate all the logic required to build the whole instance. And the second thing is we need a tool that allows us to encapsulate the results, the artifacts, the scripts, and so on. And Docker seems like a perfect tool for this task because it does exactly that. We can use Docker file and scripts to put the whole build process in there. And the resulting image can contain everything that is required, the JVM, all the required libraries, and also the created repository libs, which will be used to serve the absent libs subtrees. What's also nice about Docker is that it allows us to define the environment in a very precise way. So even though we have a lot of moving parts over here, if we can control the used Linux version, the used bash, and so on, we can make sure that nothing breaks in between. So we have used Docker internally in Adobe for testing this approach. And later on, I will say things like, so AEM, Adobe provides AEM image and so on, but don't treat it like a promise for the next release or something. It will just describe the way how it can work. I'm not a manager, so I'm not sure when and if this happens. With Docker, the Composite Node Store can work like this. So we have this Docker container. It contains the AEM instance, which runs on top of Composite Node Store. In the same container, we have the absent libs repository. And all the content, everything, the whole state of the application is saved externally. So it's quite nice case because right now the whole application code, including all the JSPs, all the bundles, everything related to the code is stored inside the container, while the whole state of the application is saved externally. Because of that, this container can be immutable, because the application code shouldn't change. If we want to upgrade the application, we should destroy this container and create a new one from the new image, which will run the new version. A few words about this external repository. It may be either a directory mounted in the container using this volume Docker directive, or if someone prefers to use MongoMK, then it can be just a database run directly or in another Docker container. So everything is possible here. This graph, probably the most complex one, but it's the last one as well. It presents the whole setup of Docker-based AEM. So basically, the idea is that the AEM will be distributed with this base Docker image. This base image will, I'm not sure if it's readable, it contains the AEM provisioning model, the AEM bundles, and also the build scripts that puts everything together. So this kind of image isn't meant to be used directly. It has to be extended with the customer image, and customer has to add their own provisioning model, and during the build process of this customer image, the repository snapshot will be created. So this repository libs will be created and included there. And when we start a container based on this image, then the libs repository will be inside, and it should connect to external repository, either Mongo or SegmentMK. So this kind of setup gives us interesting possibilities, because basically what we can do is the blue-green deployment. The blue-green deployment is a way to achieve a deployment without downtime. So this is this zero DT, zero downtime mode. So the idea is that if we use the MongoDB for storing the whole content of the instance, then we can start 2 containers, and these 2 containers can run actually different version of the application, as long as some constraints are fulfilled, and I will tell about this later. So in the blue-green approach, first we have this blue container, which runs some V1 version of the app, and if we want to upgrade it to the new version, then we just start new container running the V2 application. And they can run together for some time. During this time, we can switch the load balancer from this container to this one. And once the switch is done, we can destroy the blue one, and we only have this green. So there are some constraints on the application side, because as you can say, what happens if this container will does some changes in the content that this container cannot handle? Well, it will break, so the new container cannot do it. So this approach assumes that the new version of the application is backwards compatible with the old data schema, and if it introduces, for example, I don't know, new component, then this new component shouldn't be added to the site until the load balancer switch is done, because otherwise we add the new component, the load balancer still points to the old application, and this old application won't know how to display this new component. Or if we decide to change the property name, then the new version should check if the old property name exists, and if it does, then it should use it. So this kind of constraints are required for the. It's true generally for the blue-green deployment for any application. So now it's demo time. In this demo, we will try to do this blue-green deployment on an AEM. In this case, we will have 2 versions of the app, and the difference between the old one and the new one is that the new one introduces some new video component. So we will try to switch from the old instance to the new one, and then we will add this video component. Okay. So I actually started the instance before the presentation, because the process of starting instance always takes a few minutes, so there is no point in tailing logs for this time. hopefully this is a working instance working on the 4502 port. And there is also, let's say, a load balancer under 8080 port, which refers us to the same instance. We can add some text here just to say that that's true. And in this 8080 instance, it's true as well. So this is a working instance. I think we can actually go to the startup logs just to see one thing, which is quite important here. So this instance was started with an empty MongoDB. So in this case, there should be this process of initial pushing the data from the repository libs to the MongoMK. And it actually happens. So as we can see here, when the Composite Node Store service tries to start the Composite Node Store, it says OK. So I'm connected to an empty repository, so I should prefill it using this seed libs. So I will do this. I will include everything except the apps and libs and some permissioning data and some libs-related indexing data, whatever. So we can see here that there is a lot of nodes being copied. And once it's done, the instance carries on with the startup process. OK, so we have this working instance. And now in the blue-green approach, we should start the V2 instance. So I have done this as well. It should work under 5502 port. And we can go to the same page. OK, so what's the difference? I will now go to proxy, and I will try to add new component. And on the component list, we can see that there is no video component over here. So this refers to the old application, while this 5502 on the component list has this video component. We cannot add it yet because 1 million of customers already using our load balancer referencing the old version of the app. So if we add a video component and the old instance doesn't know anything about this, it may, I don't know how it will end. So now let's try to switch the load balancer. And and now I refresh the 8080 port, and we can see the video. So the switch is done. So now it's time to stop the old instance. We don't want to add the new component anyway because I don't know what the old instance can do with this. So we can stop it. We can trace the process of stopping. On the top tab, we can see how the old instance stops. And once it's done, we will try the new component. OK, so the V1 version stopped. Now we can actually, let's try to open it directly. Yep, it's done. Now let's try to add the new video. Configure it somehow. And here it is, a beautiful movie. OK, so that concludes the demo. And now it's time for wrap-up.
Yeah, so as a way of tying all of this together, this is sort of how we think that we can make AEM deployments, upgrades more predictable and with less downtime. From a technical point of view, everything related to Oak is already in the Oak repository, so probably will be part of the upcoming Oak 1.8 release, the Composite Node Store and all the mount time checks and all that. The Sling provisioning model is already available in Sling. As Tomek mentioned, the Docker part is something we've been experimenting with internally at Adobe. We're not sure where that will go next. Even if it's the solution we'll choose or we'll choose something else. As resources, we have this link where we started accumulating documentation. Now, if you go there, don't be scared by the huge amount of information that is there or is not there. We'll add more as we discover more things to document. And I guess this is it. And if you have any questions, we'll be happy to take them now.
Thank you. So, any questions?
Great talk, thank you. What was the size of that base image?
Right now it's 800 max.
All right. Have you ever thought about like licensing changes, as Docker is all about scaling, and if that's the future way to go? I think that maybe it would be good to consider some licensing changes, as if you'd like to spin up like additional, I don't know, 50 new AEM instances, that could be a problem with current model.
That's the kind of question that we have no idea about.
We can neither confirm nor deny that we are or not thinking about licensing changes. Yeah. Something like that. I don't know. It's not a question for us.
All right. Thanks, guys.
Other questions? Masood, just behind you. This one.
So concurrency comes to mind when we have two containers sitting in that, so both active, and you start doing something. Let's say both kick off a job in the background, things like that. So any experience around that you can share?
So in case of having two containers connected to the same MongoDB, it uses the normal MongoMK clustering code. So, and the Sling discovery built on top of that. So basically it's similar case like having an AEM cluster. The only difference is that each node in the cluster runs different version of the application. So this may lead to some troubles, like if you have, well, basically the jobs have to be compatible in terms of data schema as well. Also, in case of blue-green deployments, there is an issue that you have to wait until all the background jobs are done on the blue instance and so on. But generally, it uses the same code as the clustering, and the clustering is pretty stable. So we expect similar with the composite nodes.
Right, so just to add a little to what Tomek has said, load balancers usually have this concept of draining requests from a certain instance. So you will not be able to remove it until you have 0 requests. So you can additionally define some sort of steady state for your own instance, which says, hey, I'm not doing any, in-memory processing or intermediate steps that I would like to lose. So we see this more integrated at the load balancer level and your application reporting, where it's ready to be taken out.
Thank you.
Another question here. If I would expect little downtime, so do not have blue-green really running in parallel, as it was in your example with the MongoDB, if I can stop one and start the other right in the next moment, I mean, one of the advantages of blue-green deployment is also that I can easily switch back if something goes wrong. Can I then also use TimeK? I mean, I understood that the Mongo code is more optimized for running 2 instances in parallel, but if I just don't want to use the Mongo and accept a downtime. Is a little downtime, is this okay?
Yes.
Yeah,
Yes. You can
Absolutely.
switch the application back and forth using the tar-mk for the main repository.
Thank you. There was another question just here.
Hi, thanks for the talk. For this to be brought into AEM, would we need to restructure or rethink ETC designs and the mix of content and code that's under there?
Yeah, that's a good point. I think Florine's presentation from tomorrow will have a lot of more details on that. But yeah, basically it helps if you rethink your application, the content of your application along a set of certain guidelines. So yeah, but we will have more than tomorrow.
Thank you. Any more questions?
I think there's someone in the back.
Yeah, this is probably following on from the last one a little bit, actually. There are some things that are kind of on the border, aren't there, between content and code, especially things like workflows that are workflow models are also versionable. Do you think there'll need to be refactoring of the AEM application itself to better support this?
Well, I can say that there has been some refactoring of AEM to allow it to be more, let's say, in line with this method of deployment.
Is that like moving things to /conf and stuff like
Yeah,
that?
/conf is a part of this.
Great, thanks.
Thank you. Any more questions? Okay, thank you, Robert, Tomek, for your presentation.